giving a chat about what he's up to at Rocco's, and then we'll have a little Q&A, followed by food and drinks and pizza.
Yeah, food and drinks!
Love it. So, yeah, bear with us, and we'll get things up together. So, yeah, I'd like to introduce Jordan. Hey. Jordan works with me at Ghost Street as the lead developer, and we're going to give a short presentation tonight on a little bit of a piece of technology that we've been working on over the last couple of months. It's called Normal Camera. So we'll crack into it. So to give you a little bit of a background, we're currently a 5-person small interactive design studio. We've been working on doing websites and apps, and also working on our own website. And we're sort of faced with a bit of a challenge where we got to the About page because we wanted to show off the team. And one of the things we wanted to do was throw sort of mug shots on the website, but we wanted to do it in a bit more of a different manner than just the usual photos, or when you hover over them, people are doing the goofy expression, or you know, that sort of thing. So we thought we'd explore a few sort of technical, I don't know, explorations around the idea, and iterate on that. So the sort of concept we came up with was using the idea of a normal map, which is a tool used quite often in video game development, which I'll let Jordan explain because he's better at this part than me.
Hey everyone, I'm Jordan. I was informed earlier by Tim that I'll be giving this presentation. So I think good. Normal map. Everyone knows what a normal map is. Everyone, games. Really common technology for video games. The way it works is that you can think of it as the equivalent of an image, but for the orientation of the surface under each pixel. If you imagine an image as like a 2D map from an XY pixel into RGB color space, if we substitute the three-dimensional color space with a real three-dimensional space, then each pixel can be worth a three-dimensional vector XYZ pointing in a particular direction. This is used in video games to create a bump mapping effect. So here's a really basic sort of hemisphere thing going on. What we do is use the red channel, this one's flipped, but you use the red channel to encode how far the surface is pointing in this direction, in like the X direction, and the green one for the vertical one. And between the two of them, you can recover the data of the surface orientation for every pixel. I've got a little diagram, I think. Diagram. Okay, here's basically how it works. You can imagine the surface has some kind of detail, and then if these vertical stripes are basically where each pixel is going to land when you take the picture, we sort of keep the orientation but throw out the actual shape. And then once we've found the way that the surface points, if you like, this is called the normal vector, that's the name. You just keep the normal vector and you put that in your image, and that gives you this weird purple image that encodes these directions. So you do that once for the X direction, once for the Y direction, and together you can recover your vector. Here's an example of an actual normal map, and you can see how the red coming from one way and the green coming from the other way kind of sort of gets you back the detail that you've lost by compressing this texture into a single image. This is cheap for video games because you can just render a flat plane, apply the normal map, redo the lighting calculations as though this were really the way the surface was facing every pixel, and get a realistic bump mapping effect back out again. This process is called relighting. I'll use this in a second. Okay, so we had this idea, can we do something more interesting than just team photos? We could make it more interesting by introducing an interactive simulation that runs on top of the photo. Color data is mainly useful for humans, so I thought if we had a normal map instead, we might be able to do something interesting with the simulation. So here's our first experiment. Firstly, we figured we can recover a normal map from a real subject by lighting it from top, bottom, left, right, and then recomposing them into the two dimensions with the two different color channels. So we visually went to the storage cupboard at the office. So we took these photos as I held my phone at different angles, trying my best to keep still. And the result is the next image. So this is doing manual recombination of the different channels in Photoshop. So the way you do it is, for example, take the left image, take the right image, make this one negative, scale both by half, and combine them together, and you end up with half of the red channel being worth pointing straight forward. Maximum left is 0, maximum right is fully red. So we're using the red channel to stand that whole orientation in that direction. And then you can see there's no green in this image, that's because I carved up the green part. But in principle, it kind of sort of worked. So I wrote a simple simulation that just dumped a bunch of particles on this image.
Nope. Oh, shit. I can't go backwards.
Oh, you can refresh, right?
I can't refresh. Nope. Sorry.
Okay, so once we had the normal proof of concept, normal map thing going on, we can dump a bunch of particles on it, and you can see how you can tell the particles to sort of respect the direction of the objects, even though it's a flat image. They travel down the thing, so you can see it sort of goes around the nose and so on. So this is kind of sort of working. One thing we did notice that taking this photo is that I've moved my head too much during the process. And you get this misalignment of the different channels that looks unusual. It doesn't quite work out. So we forget. In order to do this correctly and capture a human subject, we basically need to take the photos with the different light orientations as rapidly as possible. So the idea that I had was we could build a little frame with LED strips around the edge and synchronize it to a camera and just trigger it, and it'll just go click, 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 and take all of them with it. In theory, the subject will move as little as possible. So here's a couple of sketches that I came up with. I sent these to a mate of mine who's also a developer, James, who helped me with the fabrication of this. We went with the second design, more or less. Next slide, please. Here's a couple of bits and pieces of me and James working on this thing. We've got some 3D printed parts here. There's a frame coming together. Next one. This is the finished device. So basically, the guts fit here, Raspberry Pi, we go for basically everything. Here we can basically use the official Raspberry Pi camera module to interface directly with code and a bunch of little relays. So I can use the general pins on the Raspberry Pi to trigger the lights at the same time. So the camera's on the back of this plate here. Here we go, here. So the subject stands in front of the frame, and you can see we've got LED strips, and this synchronizes in 4 directions. And we've got a couple of shots Tim took of us messing around with it in the parking lot.
Yeah.
There we go. This is our staff photo day at Ghost Street.
So yeah, the idea is that the object or the subject matter of the photo will be placed inside the frame. It would have to be we tried a number of sort of different configurations, but we sort of found that really just a single object that's in there with a really dark background behind it, so you don't get any background interference. Turned out like the best results. So.
One thing it turns out to be very tricky to do with film maps is clear company. So there's a background behind your image, it's pretty much staying there unless you're really, really patient.
We managed to sort of rig it up so that it would post on a webhook to our Slack channel. So whenever someone's using the camera, you'd know because our Slack channel, we bond with these technicolor faces of people when they're using it, which is kind of fun. So here's an example of a couple of actual photos we took using the camera, and they've been sort of recomposed, I guess.
Yeah, I managed to get the Raspberry Pi to do the resynthesis of the channels on the Raspberry Pi and just send us the finished image. So technically it takes 4 pictures, but it just smushes them, superimposes them together for me, and delivers me the finished image instead of having to recombine manually. So this is the output of the camera. This is James who worked on it. You can see it there. And now that we've got the data from the camera, we're able to capture a physical object. We can do interesting things in software, for which we're going to use WebGL. So instead of using 3D objects here, we're basically just using WebGL to run a shader script, which is basically like a GPU code runs on every pixel in the picture independently all at the same time. Which means you have to do some interesting things to get it to work. But in principle, you can do this relighting trick that they use in video games. So here's a couple of different effects. This one, you can see this follows the mouse around. So if we know the mouse position, and we know the surface, we know the orientation the surface was presenting at the time of the picture, we can recalculate the bounce angle of the light and relight it as though it were a real object, even though it's a static image. There's a couple of different effects here. This is a cool one. This is my flatmate, and I was testing it on. So the original idea we had is that we could do a different visual effect for all of the members of the team on the start page of the website. But what we ended up finding was something a bit more interesting. Originally, our idea was that building this machine, the whole point of the machine is to take the photos as rapidly as possible so that we get as little movement as possible. But through a couple of accidents, we found out that moving deliberately during the picture actually creates an interesting effect. So we sort of began leaning into this effect and getting this sort of ghostly, weird thing that happens when we run the relighter. And depending on the pose you can strike during the 1 second you've got when all the things are going off, and you can get some really cool effects out of it. This already works for us here at Ghost Street. We've got this like 3-wolf moon kind of thing going on. Here's me. I really like this effect. The thing that's interesting about it to me is that this effect is completely unique to the bespoke hardware that we created. There's no way to reproduce this with any other sort of method or even from, you can't get it from normal, using that word. You can't get it from traditional cameras. So yeah, we really lean into this effect.
The other thing that's great about it is it just takes a single image as a source, which is incredibly size efficient, obviously, for websites. And it gives you like something that you can really play around with, and literally the input is like a JPEG effectively, and you get some quite good fidelity out of it.
This is the final product. This is our stuff about us page on our Facebook website. Yeah, kind of unique effect.
So yeah, I mean that kind of, I guess, wraps it up. A lot of the fun we had with this was sort of exploring different ways of how we could take the approach, and I think there's still definitely a lot of exploration that we can continue to do. Taking the concept of like light and your choice of where the light is happening, different objects that could be lit. Could this be applied without having to do the 3 different kind of lights happening using like actual depth tracking technology and things like that? Yeah, there's a lot of sort of further avenues for exploration that we're quite keen to play around with as well. So then, that was a quick little chat from Cool.
Hey guys, how's everyone? Good. Cool. So yeah. First off, how awesome was that? Ghost Street, huh? That's pretty crazy. So yeah, my name is Evander. I'm a product designer at Rocos. And I've been with Rocos for now 8 months. And I'll share a little bit about what we do, some of the things that we're doing. I actually got asked today to do a bit of a case study. So I went to my senior product designer. I was like, hey, listen, we're doing a case study. I'd love to show something really cool and exciting. He said, you know that stuff is top secret. You can't share any of that. So I was like, well, what can I show? He's like, we can do something around the settings page, maybe, which isn't a lot of fun. But instead I thought, well, how can I change that into something that might be a little bit, fun to, or educational, so it's more of a practical kind of study around some of the stuff we're doing. Cool. So first off, Rocos is a SaaS product for large enterprises looking for a solution to connect, monitor, and control their robot fleets. And so what we see at the moment is a lot of the companies overseas especially, they're looking at what is the next wave of technology. And for them, that is robotics or automation. And particularly, how do we use robots to automate boring, dull, or dangerous tasks? And so we thought a really cool explanation of this would actually be to put a robot dog out there and herd some sheep. But the funny thing is actually someone who's in an office about 100 miles away, controlling that robot and making them actually herd that sheep, which means that there's a lot of data being streamed. There's actually live, the video stream coming through. There's the actual geolocation of that robot. And we need that to happen in real time because if that robot does something wrong, it can get pretty dangerous, etc. But some of the other use cases would be energy companies, for example. Some energy companies who have to spend thousands of dollars to get a person to come out on site and fix some of their substations. So it's a great use case for a robot to come in, or even construction sites that can be particularly dangerous. And now this is a pretty new territory in terms of technology. And as a designer, I don't really have a lot of, I guess, best practices to look at, especially in the product world. You're constantly kind of looking at, well, how are people solving these types of problems, so that you can almost benchmark your design and go, okay, this is good, this is bad, we make it better. For us, there really isn't anyone doing that. So we kind of go through this really long iterative stage where we design our own inspiration, in a sense. And it can be pretty painful. And one of the things is not all robots are created equal. So we're designing for multiple different robots. Robot arms, robot drones, even the cranes, for example. So that's a lot of data, that's a lot of different controls, etc. But we get to do some really cool stuff. I think so anyway. So this screen here in particular is actually a screen that a person would use to operate a particular robot. The screen is actually a digital twin. I don't know, does anyone know what a digital twin is? Put your hand up. Okay. Cool, if you're maybe two people in the room. So a digital twin basically, in a nutshell, is a real world simulation of that actual environment. So someone's gone out there, they've mapped and they've scanned that particular environment, they've pulled it into your laptop so that you can actually measure or do anything in that world. So right now, this robot, for a person operating it, be controlling it, moving it somewhere, but in the real world, to the exact inch, that robot's doing that thing. And in real time, we need to be making sure that we're updating that digital twin or that map. Because if a tree falls down and we don't see that, we're just going to keep going. That's a $100,000 robot on the line. So yeah, we won't be too happy. So I think what I'm trying to illustrate here, though, is there's a lot of complexity towards our particular product. All right. And some of our challenges for our customers is actually more towards the boring side. It's more around security. So for example, they don't want someone to accidentally get control of their robot. There's a lot of hackers out there, and then just send their robot straight to the bank, rob the bank, And so we need to make sure that we're managing the security behind it, but also some people inside of the organization, there might be some entry-level people who don't really know how to use the robot potentially. So we need to make sure that there's limited, we need to help them choose who gets access to that robot. So entry-level people can just have a look at it, and they don't, accidentally send it off a cliff, for example. Because this is literally what people worry about. Every time I say we work with robots, it's just like, oh no, they're going to take over the world. And in a nutshell, what we're trying to design is a feature that enables roles and permissions, that's really basically it, right? The thing that we kind of struggle as a designer is the market is too early for roles. And for example, we can't say there's an admin for robot. We can't say that there's a, the market is too early for roles. We don't want to start creating roles and then pushing it onto companies. We need to be receptive to see how they use the platform, how they control robots before we start going down that road. And as well as that, because we know that roles and things are going to adapt as the market matures, we don't want to build a lot of UI or technical, or dev that's going to be changed in the future, because that's just going to be a lot of debt that we have to cover. And so one of the things I want to first off, probably should cover this earlier, is who is the end user? Basically, they're developers. They're they're developers who are looking to control the robot, build all these missions or these different tasks for a robot to go from A to B. And what they're looking for is, I guess, maximum control over that particular robot. There's so many things that a robot can do. They want to be able to do it all. And so that's kind of the challenges that we have to face with. So in terms of where we start as a designer, we always start with what is the jobs to be done. And does anyone, I just want to see a raise of hand, does anyone know what jobs to be done is? Yeah, a couple. Yeah, cool, great. So this is kind of used within the product design world. It's pretty much what is the purpose of that particular feature that you're trying to build, or who are the people that you're serving, what are their needs. And for us, we always start with this because we need to make sure that we're solving the right problem first. For us, it wasn't about actually limiting or making roles or permissions. That's kind of the feature. What we're trying to do is make sure that the developers, they have the right amount of access to the technology. For example, if you have an entry-level person and they need to do their work, but they've got way too much access, they will accidentally put the robot on fire, for example. But that's some of the stuff you need the seniors to access, right? But on top of this, you might need an operation manager who's managing all of this. They just need view access, right? And so we're always trying to look at that lens first. And so within that, we're also looking at gather requirements, need to understand the technical constraints, etc. One of the things that I've learned is that as a designer, you don't automatically join the robotics team. So I need to really leverage their knowledge to understand what to build. So the first thing I always start with is I conduct an interview with the actual developers on our team. And that's really hard because I'm not a developer. I need to understand what they're doing, what they're trying to say, and that can be a long process, but it's really important within our world at least. So the first version which we built was kind of like this, and basically we listed all of our features down the side because they need that much, customized. They need to be able to see all the features. They want to customize all of that stuff. Anything green means you get access. Anything red means you don't get access. It was kind of straightforward, and we thought this was it. So we designed it in high fidelity. This was like a week's worth of work. And what happened was they were just like, yeah, no, it's not good enough. And this is what you deal with, and it's quite often we were kind of dealing with this also because we weren't understanding the technical constraints within the scope. Everyone had an opinion, and we had to realize that this is something we couldn't build by ourselves. So instead, we went back to the old workshopping method where we just got everyone into a workshop, all the stakeholders in the room, and we thought it'd be a great way to get buy-in as we develop this really kind of simple feature, but everyone had an opinion on. At the same time, we managed to tackle a lot of tough decisions. And one of the decisions was that we need to focus on the end user. The end user was a developer. They need to be able to customize everything. So we're like, yeah, sure, let's do that. The thing as a UX designer, as I kept looking at this kind of problem, was no matter what way we go, it's going to be really complex to design the UI for. Really, really complex. And you'll kind of see at the very end what I actually designed, and you'll be like, well, I don't understand any of that. And basically, what happened was, as I was designing it out, I was like, okay, I'm the UX designer. I need to make this more user-friendly. So I actually went away from my senior management. I was like over here. I was like, no, I'm going to make it super user-friendly. I'm not going to listen to what you guys say. I'm just going to make it really nice. And then I went back over here and I presented it to them. And they were just like, yeah, no, it's not good. You shouldn't have done that. You shouldn't have done that. And it was a hard lesson for me because I kind of felt like as a UX designer, my pride was coming through, and I was like, I need to make this more user friendly. But really, he brought me back down to earth. He was like, listen, the end users, they don't want it to be user friendly. All right, they just want it to be. They just want it to have all of the features in there so that they can, customize everything that they need. And I was trying to find that middle ground, but they there were too many opinions within that. So I decided, no, I won't go down there. So lots of iterations, a few more workshops later, we ended up to a conclusion. And it kind of looked like this, right? So this is the type of UI that I get to design for Creative Fun. And basically what it is you'll see three almost like JavaScript code blocks where someone can come in and they can, one, assign a user. Well, first off, they create a role. Then they come in and they assign a user to this particular role through the use of tags. And if you've used tags, it's similar to, like, I don't know if you've ever used Shopify, where you put a label onto the different items. And then you can use that label to search through and quickly find that different item. What we thought would be awesome is if we had the ability to add labels to different users so that you could create rules, including adding them to a role. If a user includes a label or a tag, they'll be included within this role. The second thing is we can do the same for robots. So now you can add robots into this role. And the third thing is we can actually set permissions. If they have a label such as XYZ, that person or the person in this group can access and control that robot. And the great thing about this is you can pretty much code everything within 3 easy steps for a developer. And I think this is one of the jobs where you kind of like, you go home and you kind of like, man, that was a tough day at work. Just trying to wrap your head around some of the subject matter that you need to understand to successfully design your feature, right? So summarize some of the things we learned is start with the jobs to be done. Make sure you understand the reasons behind some of the decisions before you go off and go rogue. Something I've learned the hard way. And yeah, I think one of the things that really humbled me was actually learning kind of like the technical side around some of the product features. And that's helped me grow a lot. I think if you can have more conversations with your developers, you can actually learn how to build out these products within your mind and design more successfully. And then just iterate, which is kind of the age-old saying, but yeah, it's true. Yeah, cool. Thanks, guys. That's me.
Thanks, Amanda. Yes. I will do a short little Q&A if anyone has any questions for Amanda, myself, or Jordan about anything you've seen tonight. Or not. Oh! It's a good one. How about learning how to put my data? Yeah. Not really. No, I think within our environment, first off, make sure that I understand the actual problem behind a lot of what we're trying to design before I decide to go and present a new solution.
But also, one of the things, if it's decided within a workshop or from multiple different stakeholders, don't go against that. it was multiple people decided that, and it's actually better because you're getting buy-in from many people. Go with that instead. Yeah, in retrospect, I thought it'd be better to go against that and make it more user-friendly. So yeah.
Well, I was curious about your tag system. Do you have like not operators and brackets as well, or you really got hands and all?
At this stage, we basically just made like a massive JavaScript weird block object, so anyone can write anything. Yeah, anything and alls if.
So what's the screen look like that got shut down?
It was
compared to like a full.
Yeah.
So you've got Boolean.
Yeah.
Boolean,
Yeah.
Boolean logic system.
Yeah.
You can do anything.
Yeah.
I'm curious what you designed before that.
It was basically a one field that said like does contain or not contain. And it was
you can't do anything.
Yeah, you can't do ands, ors, and the benefit was like does contain or does not contain. You can read it, you can quickly understand. Okay, that's what that
Can you
means.
put multiple lines of it afterwards though?
You could add a line afterwards, but you could only does. Yeah.
I got one more. I was curious about your one. Could you turn it into video? Because you're taking nearly static shots. And you could probably do it quick enough. I thought the second dimension was time. So now you've got the first dimension was 3D, and the second dimension now is like time. So it's like, oh, that would be quite amazing if you could do that.
In principle, you could, but you start running up against the limit, which is how quickly the light will saturate the scene, how quickly the camera will capture the data, and then when the light turns off, it will desaturate the scene, ready for the next light to saturate from a different direction. So you've inherently got the cycle of the LEDs warming up and cooling off again. That if you're too quick, they pollute each other as they go around. They don't quite finish up before the next one kicks in. So you're restricted to about half a frame a second if you do it right. So you could theoretically do video. You could do a sort of a stop motion vibe, I guess. But you'd really have to tune the thing to work properly. We couldn't get it that fast on Raspberry Pi. You'd need an external camera like a DSLR to use with an external mic.
I really love it.
I've got a question for you guys. How did you guys come up with the idea? Like,
it's kind of something like we sort of poke around the video game stuff from time to time, and
did you guys know you could build or code it up before the idea sprung, or you just like idea, let's just do it?
I worked with normal maps in the context of video games before, so I knew in principle how they worked, and we were just stuck with the option of doing something boring. I was like, let's jam a screwdriver in this. I'm sure we can come up with something. The idea came from, can we get it to do something interesting interactively? Which the options are much richer if you've got much more structured data than just like a photograph.
Yeah, previously we've used WebGL for a lot of other things, so that had exposure to normal maps. And some thing I always run up against is, we can make a nice texture for this thing, but if there's actually a nice normal map on there, then we can light it really nicely as well. And I was like, how the heck are we going to make this normal map for this thing? Like, can we just budge it together in Photoshop and sort of jam it together? Or is there another way we can actually go about making it? And it was sort of the case of going back to, well, what is a normal map? And how can we actually generate that ourselves? And can we just do it with 3 photos we just smash together in Photoshop? Turns out it can. So, yeah, just kind of taking a step back and trying to reorient the problem and the idea.
What's the feedback been from clients, and have they offered you like any jobs similar to that? Because
Well, it's only been up for about a week.
So would you guys be looking to get work in that sort of area?
Sure, yeah. Any opportunity that we can take to weird, interesting visual effects and processing tricks.
Yeah, it's like a whole month of just getting some photos on the website. But,
How big is the JPEG?
just a regular JPEG size. type files?
It's a couple hundred. Technically, it comes off the MPEG stream from the camera module, so you can't get very high quality. But they're 1024 square. Yeah, a couple hundred K. Yeah.
With a better camera, you'll be able to get better imagery. It's just the cheapest camera in the world, the Raspberry Pi. So.
Simplest thing that works.
Awesome. Good. Well, good. Thanks everyone for coming along. It's always great to have everyone here. We've got some food at the back. If you do want to speak at one of these things, feel free to hit me or send the guys up.